There we go. Y'all, it's already February. Oh, my Lord. Tomorrow. Tomorrow. That's crazy. All right, here we go. So we're going to very quickly talk about the reference angle. And you've already seen this in your homework. And I said, no, just ignore their directions, follow my directions. You may also see it called the reference number. The reference angle, the reference number, it's all the same. I don't know why they call it more, just decide on a name and call it that. It's because we're talking about the unit circle. It's very important. Aha. All right, so what are we going to do with it? Okay? Well, it's okay. All right. All right, so you got axes, okay? X and Y axis. Let's say that I'm graphing this angle. Now, if you see me prepare my graph that way, which angles am I getting ready to graph? 45s, or in radians? Pi over 4, attaboy. Now, I'm graphing this angle right here. What angle is that? 3 pi over 4, very good. That is the angle T, 3 pi over 4, okay? Just for kicks, what's that terminal point? Come on, folks. Attaboy. Negative root 2 over 2, positive root 2 over 2. You guys agree with that? You just listed this somewhere on that worksheet. I'm sure it was somewhere on there, okay? Now, well, that's the angle T, but we're talking about the reference angle, okay? If you look at this, there's a portion or a slice that will get you close to the x-axis, isn't it? This piece right here will get me back to the x-axis. Do you guys agree with that? Okay? That portion, that angle, can't really tell that. Let me do that again. That angle right there, that's the reference angle. The reference number, okay, if you will. And I want you to think of it this way. A reference angle is like this. Most of you guys, because I don't make any bones about it, I just, well, mainly because if you've been driving near me, I have the need for speed. I like to drive fast, within reason. I'm only 5 over, okay? And I like to drive down 58 to my house because I get to drive fast on 58. Little windy roads, don't get to drive as fast. Can't be as safe, but on 58, put the hammer down. Get out of my way. Don't get in the hammer lane in front of me. Get over in the granny lane. Get in the granny lane if you're going to drive a speed limit, okay? Now, let's think about this. So, if I go down 58, I'm going towards Martinsville, right? So, I can go to Spencer the quickest way going 58 because I live in the heart of Spencer. Don't tell me, well, my address is Spencer. Oh, I live in the heart of Spencer. Don't be talking. If you don't live near the international airport, then you ain't living in Spencer. And I could throw a rock really hard at Spencer International Airport. Okay, now, here's the deal. Reference angle. Who cares where she lives? How does this tie into the reference angle? This is how it ties in. The shortest way for me to get home is down 58. Or I could go down 8 and cut across Ayers Orchard and go that way. Which is going to take me the longest? The second way. I could also go down 8, go to Sandy Ridge, cut through Amostown Road, go up George Taylor, and I could be in the heart of Spencer in a shorter time, longer time. And that'd probably take me about 35, 40 minutes to get home if I went that way, okay? But it's doable. The point being, reference angles are the shortest way to get to the x-axis. The reference angle is the shortest distance to the x-axis. If I'm in a hurry, which I always am, I'm going down 58 to go home, okay? I ain't going through Sandy Ridge, going by Pinto's, get me a cheap, great cheeseburger, and then go home? No, no. Y'all know about Pinto's? How many of y'all been to Pinto's in Sandy Ridge? It's the cheapest place on earth, and it is so good. Y'all need to go to Pinto's in Sandy Ridge, just saying. Now, shortest distance to the x-axis. Again, who cares about Pinto's? Me. Here we go. So you should too. The reference angle is also called, if our angle is t, our reference angle is called, this is so weird. Why do they have these weird symbols in math? Check this out. It's like half of an arrow on top of the t. Now what's that called? That's called, it is kind of, it looks like, well, but no, when you get to statistics, there is such a thing as a t-hat or a p-hat. It's not that or fat. It is really something called something hat in statistics. With Elvis hair? Who? Don't, it's not a hat. Don't. Why? It's bar. It's a bar. It's a bar, not a hat. Stop talking about the stinking. It's a T-bar. It's a crowbar. Okay, good connection. Who cares? There's weird symbols. All these symbols. But it's called T-bar, and that's the way I will refer to it, only because I don't want to write out reference angle every time. Okay? T-bar. Now, it is the shortest distance to the x-axis. Can the reference angle be negative? How many? Who said no immediately? Somebody said it out loud. Why, Kelly? Because you can't have a negative distance. Okay? Reference angle will never be negative. Because you can't have a negative distance. Okay? Can't have a negative distance. So let's look at another one. If I were to draw this, I'm preparing my graph. Which angles am I getting ready to graph? The pi over 3s. What in degrees is that? 60 degrees, right? That's my pi over 3s. What if I did this? I've just graphed this angle right here. First of all, what is that angle measure? What is it? 5 pi over 3, very good. That's 5 pi over 3. Hey, what's that ordered pair? One half negative root 3 over 2. Do you guys agree with that? All right, that's just for kicks. You don't ever have to list that unless you're told. But what's your T-bar? Not. Oh, good question. If I'm giving you the angle in radians, then your T-bar needs to be in radians. If I give it to you in degrees, then your T-bar needs to be in degrees. Very good question. Pi over 3, why? Because I have 1/3 left to get me to the x-axis. So our T-bar, our reference angle is pi over 3. Does this make sense? Okay? Questions at all? It's the shortest distance to the x-axis. Shortest distance to the x-axis. It will always have the same denominator. Yes, ma'am. Very good question. All right, so let's take this a step farther. What is your angle given is 5 pi. Have we just done that? Did we do 5 pi over 6? Okay. All right, we're looking at the angle 5 pi over 6. I want to know what t-bar is. I want to know what the reference angle is. Some of you will be able to look at this and go, I know what it is already. Because in your head, you're thinking math. If you're visual like I am, what am I thinking? First thing I'm going to have to do is, I got to graph it. Okay, I've got to graph it because I need to see that leftover portion, okay, or that piece that's missing. So 6. How many x's am I going to draw to prepare my graph? 2. Am I going to rotate up or down? Up. And it's going to go 1, 2, 3, 4, 5. How many 6, bless you, will I need to get to the x-axis? 1. So my t-bar is what? Pi over 6. Have you figured out how to do this mathematically without drawing a thing? What am I going to do? I'm going to take 6 pi, take away who? 5 pi, which gives me 1 pi, and then you throw it over the denominator you started with, right? So sometimes you're not going to have to draw it at all. You can just do the math. That's another way to think about this. Questions? Are we cool with this? How about this one? What about negative 2 pi over 3? Our angle T is negative 2 pi over 3. I want you to find the reference angle. You do that one for me. And when you finish that one, do this one right here. I'll draw it because I have to. All right, there it is. I got thirds, so tall and skinny, lose the x-axis. Is that going to rotate up or down? Down. All right, so I'm over here in quadrant 3. Now see, I can see what my answer is going to be. I literally see how many slices I need to get back to the x-axis. What'd you get for t-bar, for your reference angle? Pi over 3. Is it not going to be a negative? Why not? Can't have a negative distance. Doesn't matter if you have a negative angle, you cannot have a negative distance. How many of you had pi over 3 for t-bar? High five, very good. Questions at all? Not negative pi over 3. Why can it not be negative? Can't have a negative distance. You just change it. Because I just want to know how much pi, what's the distance to get back to that x-axis? Okay? And if I go this, if I land here and I want to get here, I'm going to walk, if you will, pi over 3. Whatever's. I'm not going to walk negative pi over 3. You can't do that. Okay? The distance back to the x-axis. How about 11 pi over 4? Without drawing it. See, I can't do this one without drawing it. Maybe in my mind, I'm thinking it right now. Okay? 4s. 4s are always nice, aren't they? Because we're dealing in what kind of increments? 45s. 11 pi over 4, rotating up or down? Up. So it's going to be 8, 9, 10, 11. Do you guys agree with that? Yeah? What's the distance to the x-axis? Pi over 4. And if you're not sure, then wouldn't this be 4 pi, 8 pi over 4? 4 pi over 4, 8 pi over 4. If you go back around, what would be the next revolution here? 12 pi over 4. And could I do this? Could I go, 12 pi minus 11 pi is 1 pi over 4. Mathematically, that's the way you can do this. Okay? Questions? You would go to the nearest x-axis, the nearest number that's on the x-axis. Okay? I can't do that without drawing it. Can't do it. Questions on this one? How many of you had pi over 4 one more time? Okay? Here we go. Here's another one. Your angle T is negative pi over 6. What's your reference angle? And then do this one. This is just fun. Because I want to show you on this one, what's neat about this one? Obviously, nothing is neat about this one. Thanks for nothing. Pi over 6, negative pi over 6. Rotate up or down? Down. There it is. There's the angle. Where's the shortest distance to the x-axis? The shortest distance to the x-axis. Is it going to be this or this? Did I say that shortest distance to the x-axis? I gotcha. Yes! I said the shortest distance back to the x-axis. This is not the shortest distance. That's the longest distance. Frowny face. Okay, I want the shortest distance. I want this right here. Okay, so what is T bar then? Pi over 6. Hold on. Hold on. Does everybody, have you wrapped your head around that? I need the shortest distance to the x-axis. Does everybody understand that? Okay? Now look at the next one. And to see, I cannot do this unless I graph them. Because if I rely on my noggin, or if I think I got it going on with my numbers, I will not got it going on. I have to go back to my pictures. Check this one out. Negative 5 pi over 2. Oh, these are nice. I don't have to prepare my graph for anything, do I? Am I going to rotate up or down? Down, all right? And we got to count by halves. So this is 1 half, 2 halves, 3 halves, 4 halves, 5 halves. Okay. Shortest distance. Let me just ask for kicks. What's the distance from here to this x-axis? Pi over 2. What's the distance from here to this x-axis? Pi over 2. What's the shortest? Pi over 2. How many of you had pi over 2 for this one? Very good. Very good. Do you have questions? Now, you know, the more we progress, the weirder. They're not really weird, but they're not like the easy ones. Okay? Let's look at a couple more. Couple more. Shortest distance. How about this one? Your angle is negative 3 pi. What's the reference angle? Oh, I'm a trickster. Ha, ha, ha. What? You think? How you know that? What are you talking about? Graph it. Let's graph it. Am I rotating up or down? Down. All right, here we go. Here's 1 pi, 2 pi, 3 pi. There it is. So what is the distance to the x-axis? What is it? Why, Morgan? Because you can't move anywhere. You already where you need to be. How many miles are you going to walk if you're already there? 0. That's the kind of marathon I want to run. That's what I want to do. If I'm already there on the x-axis, I'm there. So my t-bar is what? 0. Okay? Make yourself a note. If you land, well, let's do it this way. There is 0 distance back, okay, good, to the x-axis. 0 distance back to the x-axis because I'm already on the x-axis. That's a tricky problem. Just like a math teacher to do that. Okay? We're already there. Already there. And then one last problem. Everybody cool with this? If you land on the y-axis, then your shortest distance to get back to the x-axis will be what? Every time? Pi over 2. If you land on the x-axis, then the distance is 0. Okay? How about this one? Last example. This one's going to make you cry. What example is this? 7? The angle T is 17 pi over 12. What's the reference angle? What's the reference angle? I'm an artist, okay? No, not really well, but I am kind of artsy-fartsy. I'm a freak of nature. Ask Miss Harris. She says, you're supposed to like science. I hate science. It makes me physically ill. I throw up in my mouth a little when I think about it. Gross. I hate science. But she says, you're supposed to be science, math. That goes together. No. I want Glenn Burnett's teaching job. I would love to teach history. How would that work out? Can y'all see me teaching history? I would act it out every day. I would dress up like George Washington at Fort whatever. No, that's Civil War. Valley Forge. Right? Okay, yes. I would totally do that. All right, now, draw the picture. Focus. That was my fault. I claim that one. Shh. Excuse me. This is, see, that's world history. I like U.S. history. I would not wear a toga and bring in a knife. Could not do that. I would scare my students. All right, here we go. 17 pi over 12. Here we go. Half of a revolution would be what? 12 pi over 12. Another little quarter. 18 over 12. One complete revolution would be 24 over 12. Folks, when you can do that, you got this thing nipped. That's half the battle. No pun intended. I am Spartacus. I don't know what it means. Here we go. I don't have a clue. Now, 17, don't make fun. I really don't know. It's supposed to be down here, but it's in the right quadrant, isn't it? Yes. Okay. Don't be hating. Now, what's the shortest way back to the x-axis? It's going to be this right here. Folks, what is it? How many of you had 5 pi over 12 hands up? Yes. Yes, yes, yes. Now, how do I know that? Because I'm going to do this. I'm going to take my angle, and I'm going to minus the closest x-axis. The closest x-axis number. Oh, I'm not done, y'all. So 17 minus 12 pi over 12 is equal to what? 5 pi over 12. That's my t-bar. That's my reference angle. Comprende? Sí or no? How many of you feel good? Raise your hand. Go, woo! No, that was pathetic. Do it. 1, 2, 3. Woo! Oh, no. I do not want to hear any griping, complaining, moaning, or groaning. Suck it up. Do it. If you cry about this, I'm going to accidentally fall into you with my elbow, and it is very sharp. Just find the reference angles only. Don't be griping. If you don't have this homework tomorrow, you're going to get it. You're going to be grounded.